Parallel lines never meet, right? That's the first thing we're taught in geometry. Two lines running side by side forever, never touching. But what if I told you that's not always true? What if, in some places, on Earth, in deep space, or in the strange world of math, parallel lines actually can meet? And not just as an illusion, but as a mathematical and scientific reality. Sounds crazy, right? Well, stick around, because by the end of this video, your entire understanding of math and reality might change. Let's start with something familiar: train tracks. If you've ever stood on a platform and looked down a railway line, you'll notice something strange. Even though the two tracks are perfectly parallel, they seem to meet at a point in the distance. But that's just an illusion. Our brain uses a concept called perspective projection to process depth and distance. As objects get farther away, their visual size shrinks, and parallel lines seem to converge. That's why roads, fences, and even power lines all seem to meet at a vanishing point on the horizon. Artists like Leonardo da Vinci mastered this technique to create realistic depth in paintings. Without perspective, every drawing would look flat. But in reality, the train tracks never actually touch. But hold on, there are cases where parallel lines don't just appear to meet, they actually do meet. Let's explore those. Now let's take things to a bigger scale, our planet. Have you ever wondered how maps work? On a globe, we have a grid-like system of latitude and longitude lines. Let's focus on the longitude lines for a second. Imagine you're standing at the equator, looking at two longitude lines, one running through New York and another through London. They look parallel, right? But as you move towards the North Pole, something shocking happens. They meet. Wait a minute, weren't they supposed to be parallel? Well, here's the catch. The Earth isn't flat, it's a sphere. And in spherical geometry, parallel lines don't behave the way we expect. This is why pilots don't fly in straight lines on a map. They follow great circle routes, which are actually the shortest paths on a sphere. So, parallel lines do meet if the surface they exist on is curved. GPS satellites use spherical geometry to calculate distances and navigation, meaning your daily Google Maps route is proof that parallel lines meeting is more than just a math trick, it's reality. Now let's go beyond Earth and into the wild world of non-Euclidean geometry. The math you learned in school, where parallel lines never meet, is based on Euclidean geometry. That's the kind of math that works on flat surfaces, like a piece of paper. But what if space itself wasn't flat? Enter non-Euclidean geometry, a world where parallel lines do some really weird things. For example, in hyperbolic geometry, which looks like a saddle, parallel lines don't just stay apart, they actually move away from each other. And in elliptical geometry, like on a sphere, they eventually meet. The ancient Greeks believed Euclidean geometry was the only way to describe the universe, until modern physicists proved that space itself doesn't follow Euclidean rules. Alright, now let's push your brain to the limit. What if I told you that space itself is curved? That's what Albert Einstein's theory of general relativity tells us. Massive objects like stars and black holes bend the space-time fabric, and that means parallel lines don't always stay parallel in deep space. We see this happening in real life through gravitational lensing, where light from distant galaxies bends around massive objects. In some cases, light rays that started off parallel actually meet due to the bending of space. Without gravitational lensing, we wouldn't be able to see some of the most distant galaxies in the universe, proving that even light follows the rule that parallel lines can meet. So, what have we learned? In everyday life, parallel lines only appear to meet because of perspective. But in the bigger picture, on the surface of a sphere, in curved geometry, and even in space-time itself, parallel lines can actually meet. And this raises an even crazier question. Is the universe itself curved? If so, does that mean everything we thought we knew about straight lines is an illusion? What do you think? Are parallel lines really parallel, or is math playing tricks on us? Let me know in the comments below. And if you love mind-blowing concepts like this, Hit that like button and subscribe for more mind-bending discoveries. Turn on notifications because trust me, the next video is going to change the way you see reality.